Let me start off by welcoming everyone. Thank you all for attending this magnificent Swedish APL user meeting. And as Morten suggested, why not make a little bit more room for our Scandinavian friends and turn it into a Scandinavian APL user meeting, or a scandal, as Morten put it. I'm very glad to see not only Danish people, but well, we've got one person from Serbia, one person from Germany. Morten claims several nationalities, and well, we've got Indians from Gothenburg, but you're Swedish now.
Yeah,
so
like that.
So you're Swedish, okay. Right, last time we Brits, well, they're quiet and kind, so they're making a big fuss. We've got two Brits here, my colleagues Sam and Jake from the UK. Assyrian. We'll probably never hit the topic of today if we continue down this route. But yes, we've got one Assyrian as well. Right. In the last meeting, we discussed whether or not we should stop presenting ourselves and talk about coding. And we are trying out this series of meetings where we will talk about specific subjects. The web services sounded like something chic, hip, or cool. I don't know what the in word is now. Yeah. So we're APLers. We do things a little bit better, a little bit later. So 10 years after it's hit the world, we start looking into it. Nah, that's not fair. Web services. Most people in the meeting claimed to have dabbled with it at the very least, and had some experience with it, and we're curious to talk more about it. So let me just start off by asking if there's anyone here that doesn't know what a web service is. You can leave them. Right. Okay, no hands. I don't know if we've got any online people here, but no. Right, so what is a web service? Anyone wants to have an explanation?
Remote procedure call.
A remote procedure call, I hear from the back. Yeah? Anyone against or add to that? Well, I think it's a bit vague because I think most people that work with software might have an idea of what web services are, but I don't know if anyone has a clear, distinct definition of what it is. I will not claim to have the exact definition of it, and I'm sort of grown up in this Google era where you say a web service is any piece of software that makes itself available over the internet and uses a standardized XML messaging system. Do you agree with that? No. XML is used in code for communications to a web service. Okay, let's stop reading there. So clearly, there are different views on what web services are. But I think if we take a step back and, well, either look at more reliable sources like Wikipedia, we will. I think we can agree on one thing. A web service should be a service that is platform independent and provides a service for any sort of client endpoint. So a client endpoint that isn't specific to a platform that communicates with an agreed standard. That typically that would be either XML or JSON or a similar transfer mechanism that is sending requests and receiving it over. May I say the HTTP protocol? Is that the very definition of a web service?
It's not very web otherwise.
I'm sorry?
It's not very web otherwise.
Yeah. Well, I was going to say the HTTP protocol, and with my subject in mind, my topic is WebSocket, and WebSocket is a protocol that isn't an HTTP protocol, but it's sort of an upgraded protocol on top of HTTP. So I will count that in, if I may. Right. So that's a very long introduction, in my opinion, because I've already run into 10 minutes into my own presentation. I've got so much I want to show you that we'd better get started, I guess. Right. Let's see. Web services and WebSockets. Let me start an APL session and see if you can all see that. Does that read well, or should I increase font sizes, etc.?
Yeah. That's fine.
Yeah? Right. WebSockets. Do you know what a WebSocket is? Standard. Let me see. The WebSocket is a way to provide something similar to a standard TCP socket, but over the web. So typically, when you have a web client and a web server, you communicate over the HTTP protocol, and that communication is always client triggered. The client asks the server for something, a resource, a page, a remote procedure call via SLOP or something like that. All that goes through a client-initiated request, and the server responds in some fashion. What that means is that a connection is established from the client to the server, and the server does the handshake and responds appropriately to a request. There isn't any way for the server to initiate communication to a client over the HTTP protocol. To solve that problem, another protocol was developed to start a communication between the client and the server, but to keep that connection alive for as long as they want, and allow the server to initiate message to be sent to the client. So it's a little bit like going around the circle where you establish a connection, you set up a protocol you're communicating, and then you decide to not drop it, but keep it alive for as long as both parties are interested. This enables the server to send messages to clients. And when is that useful? Good question. I spent a bit of time implementing WebSocket in MiServer 2 actually, and then upgraded it to run on MiServer 3. And then thought about what sort of features I could build to demonstrate WebSockets. And I came up with See if it starts up. Right. Rumba. Oh, that's brilliant. I've got a typo in here. A very interesting web page. I've kept it all very simple because I want to demonstrate the code behind it and I want to avoid overcomplicating things. So this is a very, very simple web page with 3 different examples. And I will try to invite you to join this. I don't know if you've got your laptops up and running. If you would like to try to connect to that IP address on that port, so it's 10.21.16.20 on port 88.
On which network?
It's the Sky High. Right. I will open up WebSocket window. See if we can keep these side by side. Right, we've got someone on there already. Hi, Ender. Hi. When I got this sample working, I rushed into the living room with a big smile on my face and showed my wife. Said, "Look what I've done." And was met by a blank look. And after a quite awkward moment, she looked at me and said, "You know, I've got this thing called Facebook. They've got an amazing chat room. I can show you how it works." So I know I'm not reinventing. I am reinventing the wheel, but the point I wanted to make was that having a chat application is a typical case where you would want to get as immediate responses as possible. I'm not claiming that WebSockets are the only way to do it, but being able to broadcast messages to listening clients as soon as you get them in is a good example of where a WebSocket would be useful. It logically makes sense that when the server receives a new message, it can trigger the broadcast to the listening client. An alternative option, of course, is what I called the toddler approach. It's also called SSE or something, and a long-haul version of that, where the client, like a toddler, asks the server every second or so if he's got any status change to report. Are we there yet? Are we there yet? Are we there yet? Do we have a new message? Do we have a new message? Do we have a new message? Which, of course, is causing a lot of overhead because the client repeatedly sends a request to the server and asks for a response. So it's taking up resources on the server side. An alternative approach, of course, is to just say, "Are we there yet?" And the server waits, and then when someone sends a message, it says yes, and sends a response back to the client. Long call is what they also call that approach. So yes, there are ways of coding around this, but the natural way would be to use Focus, where there is an established link. You know that your clients are waiting for some information. The connection stays alive, and you just broadcast messages. Right, I've got another example. The voxel painter. Well, let me maximize this and see if Ender is kind enough to join me on this one as well. There are some instructions for how to control this, but I guess this is what people would call a Minecraft sort of thing, where you've got this board with boxes. I think too much. I'll just go to here to navigate this. You can swivel it and turn it up and down and around, navigating it. I haven't written this. I'm not claiming to have written this, but I took it as an example just to show when you would want to do this sort of WebSocket sharing. Someone is building on my little voxel world. Using the numbers 1 to 6, you can change the color of the boxes, and you can collaboratively build up a world. I've just taken this from an open WebGL project library. It's a sample from 3.js. So I've just downloaded this, and what I've done is put the man in the middle. I've injected myself in the middle of the code where the user interactions are called, and I'm sending them to the server and then broadcasting them to everyone who's logged on at the moment. So all user interactions are broadcast. Another example is where you would want to broadcast messages between clients. The last one is a bit more mysterious. My last demo here is where the client doesn't do anything. There is no user interaction from the client end. Just needed to find my actual session here. So if you are connected to it, you'll see the text there describing what you may or may not do. And I will manually create a table here on the server end and just demonstrate how triggering something on the server side generates new content on the client side. So if we do something like this, it gets pushed to the client and then rendered in a very simple table. Again, no styling to keep it simple and make it easy to follow the code. And if I change a value here, say Gil, you see how that's immediately reflected there. And I can do a little scan here. An example where we, for the duration of a second and the frequency of 100, update or switch a bit on that 10 by 10 grid. And every time a change happens, it's serializing and sending the data to the client and rendering it. And if we increase that, we can see that it doesn't quite manage to do frequency of 500 per second in this implementation. But basically, that means that it takes about 2 milliseconds to serialize and send the data to the client and render it on the client side. 2 milliseconds per 10 by 10 grid. How important is it that a client sees a big data table in real time, if we call it real time? It's really down to your application. Maybe in some applications it is important. This way you can push, and I have to say, oh, hello, what happened there? I have to say that this implementation is in no way optimized to deal with small changes to small parts of a bigger grid. This is just forecasting the entire grid every time it changes. I'm not going to debug that, but I thought I'll just show you what the code looks like for this bit that is broadcasting the message. So I've got a trigger function with some names defined, and every time any changes made to these variables, it gets all the open WebSockets for this URL, finds the client, and then serializes the table and sends it to the client. So this is the latest magic that sends the data to the client. Right. So I'll show you 3 examples of when WebSockets are a better choice to traditional web services, as it were. WebSocket as the transport layer for web services. Any questions at this point where you think, well, like Morten, well, this isn't a web service, or what's the point of this? This isn't applicable to us. Or tell me more about what other things I can do.
Not right.
Thank you.
Very interesting.
Right. So a web service, RPC. Peter said RPC. Well, there are protocols that there are frameworks that use the WebSocket protocol to provide an RPC service. So RPC is an example of that, where all you do is establish a WebSocket connection to the server that provides the service, and then you use an established mechanism of sending JSON serialized requests over the WebSocket, and you get a response back. So that's a web service. It's on top of WebSockets. It cuts out the overhead of establishing connections. It arguably can deliver faster throughput because of this. And it's relatively easy to use, especially, I think, where the client is a JavaScript application, where the objects are already in JavaScript, basically objects. They're just simply serialized, sent through to the server, and back comes a JavaScript object.
Are you using a standard JavaScript state binding library for this? Have you written your own?
No, I got someone here mentioned that they were experimenting with Angular, and what I wanted to do was demo how we use Angular as well for our Cosmos project, and I wanted to just demonstrate how you could use a framework like Angular to drive data. So this particular example is an Angular application. So let's take a look at the different parts of this. Let's see if I can find it elsewhere at the project. Right, live table example. Hope you can see all that. There isn't that much to it. We've got a couple of libraries, the Angular library and our application code. A little bit of text here with information, and then further down we define a little table using an Angular mechanism, which is creating table rows by repeating through a vector of vectors. And within each table row, it's then creating a cell, a TD cell, for each item in that vector. We also have WebSocket stated under the name of the table within double curly, which is the format that the Angular framework is using for injecting properties.
So the ND repeat is an Angular.
Yes. It's a directive. Thank you. So with Angular, it's an MVVM model view model framework to map data from a model to a view and back. If we look at the application code to go with it, we've got a controller, which I call practice controller, with a scope, 3 different properties in the scope, the status, the table name, table rows. I establish a WebSocket connection to this URL, slide table, and when it's opened, this callback is fired, which is simply setting the status property to the scope to connect it. And we've got a similar thing on close, so it's updating status to disconnected. And when it receives the message, it's parsing the data that is received and then sets the properties in the scope, and the $apply is basically a mechanism to trigger the update of the view. You need this when you deal with asynchronous changes to the scope. Right, so those scope properties relate to these curly, double curly names that we find in the HTML file. And that's all there is to it. These 2 files, plus the Angular library on the client side, and on the server side, we've got very simple. There we go. Not that simple. Oh, sorry, clearly I'm not awake. It's very simple because I don't have any user interaction, so I don't actually have that code in a separate MiServer page because there isn't anything listening for user interaction. The server-side code was what I showed you earlier, which is the thing that's generating, let me see, which was this data binding namespace. Hello. Why does this happen? It seems to happen once in a while.
Why does what happen?
I lose connection to the session. It just freezes. There we go. Yeah,
have you got suspend threads on error enabled? Right. Maybe. Right, all the way over. Yeah, pause on error. You might want to untick that.
Okay.
Is that on by default?
Yeah. It's on by default because that's the safe setting. Right? Okay. If you have a server that has 100 things happening a second,
yeah,
then you want to fix that. So that if you have an error and you need to debug it, there will be no moving parts.
Right.
But sometimes when you're debugging a server, you have a problem that people block the server thread. And then if one of them is on your way, I'm not sure exactly.
In an external, be a local.
I'm not sure that will solve your problem.
Okay, now I can see. Okay, that explains it.
Yeah. We are experimenting with the new ideas to allow you to declare threads as service threads, so that all your application threads will block, but
Right.
things that are running on machinery.
Okay. Right. So yeah, apologies. I probably started in the wrong end, but this is the server-side code. There isn't any client-triggered action on this last example. So because of that, I'm retrieving active clients whenever a change is made in the workspace, and then broadcast it to the client using this send text method. So so that's all you need. These lines here and those two files for the Angular framework to display the data content. There isn't anything else to it. And if we look at the other examples, I can't remember where my server is placed. Is it here? Pages. No. I'll check the source code instead. So similarly, for the chat example, we've got this bit here. To create a WebSocket endpoint in MiServer, you create a class deriving from the MiSocket, which is the new class I've introduced. And if the MiSocket class exposes some public methods to as callbacks on a new message being received. So there are binary messages or text messages or other control messages that you may receive. All of those are exposed using this mechanism of overriding the defaults. So if you're not interested in handling any of the other events, you don't need to do anything. This could be an empty class. If you're only interested in text messages, you override the default on text message, and as an argument, you get a WebSocket instance that contains the payload and methods to send data. So in our text, the chat application, this particular piece of code is dealing with fragmented WebSockets, which is something I just want to test to make sure that it works, but it's not required. All you need to do is receive a message from a client. The argument is the client instance that you received. So you inspect the data you received from the client, and then you broadcast it to all the open WebSockets that you currently have to this endpoint. And there are some helper methods in here. So get open WebSockets when called from MiSocket instance will return WebSockets that are still open and that's connected to the URL of wherever that chat file exists on your file system. Yeah?
You put the same line of code twice. Almost exactly.
Sorry, where's that?
Well, I mean, the get open WebSockets. I mean, what's in uncompleted fragment transfer is essentially the same as your else.
Yes. No, that's what I was saying. Ignore this part here because it was something I was experimenting with.
No.
Was to deal with fragmented messages. So all you need for your chat is this bit here. Oh, I should cut it down before too late. So that's the chat version. I should add that I forked the MiServer project for this just to try it out. I haven't asked Brian to merge in the changes yet. Mainly
Brian
because
will be joining us after lunch. when it's
Right.
breakfast. I mean, when
When it's time
it's a sensible time to get up in the US.
Yeah. So we can look at that then. Right. If you are, I mean, if you have tried MiServer before, you'll know that my pages are sorted dialog scripts, and by default, if you navigate to a page relative to the web root, so in our case, the web root is the WebSocket server folder, and by navigating down to /voxel/index.html, it will serve this file, and if you do /voxel.dialog, it will instantiate this class and let it render the request. And basically, to create the WebSocket endpoint in MiServer, all you need is this file here, which is deriving from a MiSocket. It will deal with the upgrade of the protocol for you. So once the client has connected, you don't receive any requests until they start triggering these text callbacks, at which point you can handle the request as you choose. This is a voxel example where, as I said, I put in a third man in the middle sort of thing to catch all the events and store the building process in a vector that I've just called #games, and then play it back to new clients. New clients make a special request to get the board.
Short question. Do you have any ways of rejecting a WebSocket connection?
Of rejecting a WebSocket connection?
Clients ask to upgrade to WebSocket. Will you always accept that, or do you have a way to say from the server side to say no, we don't want to upgrade to WebSocket?
Well, if you don't have a MiSocket page on that URL, then it won't connect.
The APL application would like not to have the WebSocket.
You mean they can't? No, we're not discriminating. Why would you do that? Everybody's welcome to the kit. No, I haven't worried about that yet. I can't remember if I'm also allowing you to override the upgrade attempt, at which point I guess you could.
You would reject that at the point.
Yeah.
Race or religion?
Yeah, exactly. Well, it could be that your web service is limited to Swedish APL users. No, I don't know. Huh?
Maybe you're too basic.
Yeah. Well, that's a fair point. I mean, if you're thinking about load balancing or restricting it that way, then yes. But then it wouldn't be limited to WebSocket. As in, you might want to limit the number of connections in general.
Yeah.
Right?
What about HTTP2? That's supposed to have some sort of server push related functionality. Can that replace WebSockets? Or
I haven't actually looked into 2, and I won't repeat what I've heard, but it hasn't been good. It doesn't sound very promising, but I don't know when. We'll see more about it, I'm sure, soon. My topic was actually to show how I've implemented this in both MiServer and Rumba, but I'm fully aware that people probably don't know what Rumba is. Nobody says anything, so. Yeah, it's a dance. Just like a conga, Rumba is a dance. Foreman First thought that the MiServer project was getting too big to do simple things and wanted to write his own because he's an APLer. So he created this Rumba project where he's writing an HTTP library which offers both client and server code to initiate connections on the HTTP protocol or to serve connections. So HTTP server and client capabilities. And we found ourselves using almost none of the fancy features of MiServer in Cosmos. So we happily tried it out. We've been trialing it for a month, and I took it upon myself to implement WebSockets on that as well, just to learn more about Rumba and to see how well it fits in with things. And I now have MiSockets implemented in that as well. Rumba isn't giving you all these easy, what is it called, Ewok features, or have you abandoned that name now?
Well, I mean, and that's the generation of the user interface.
Right.
Another layer. No, they've not done that. I'll try to summarize that a bit later.
No, the name I meant.
Oh,
I can't remember if it's still referred to as Ewok, but
no, it's actually now referred to easier than
Easy Ewok. Okay. Is that the dance? No, it's happened again. Morton. If I don't look at it, it gets upset.
Maybe that you put a thread on a wait to Conga,
Maybe.
and it's not responding until you come back from that wait. It's in a DLL call, which you might get.
Right.
And then once every 30 seconds or something, you get a time slide.
Okay, so I've got about 14 minutes to just quickly demo Rumba and what Rumba is like. To create a server in Rumba, we can take a look at our little, well, I'll show you the Samba version of Rumba. Well, from the outset, I was told that I was not to interfere with Rumba too much because it's supposed to be a lightweight and small HTTP library. So I've tried to avoid changing the core code of Rumba. But to implement the WebSocket, I was forced to interfere a little bit with Rumba, and I had to give it another name because it was supposed to be an extension to it, so I called it Samba. Yeah, I know, this lovely names. I'm sure you all agree. But in its simplicity, you only need a few lines of code to start a server, and what you the core important details here are to define the port that you want to listen on, context namespace where all your callback functions will fit and serve requests, and the entry point here, so the on request callback that is triggered when you get the request to the web server. So there's a few lines you need to define, and you're up and running. Because Rumba is so lightweight, it doesn't actually handle much like static file handling. That's too much for it because it's not supposed to deal with static files, right? So it's arguable if you really need it. As a standalone web server, you would need to be able to serve static files. But in my experience, sitting behind Apache or IIS to serve all the boring stuff and handle the majority of the traffic, and leaving the APL to just deal with calculations or getting at resources, special APL resources, makes it snappier. So if you don't want to put it behind IIS, etc., you need to worry about these other things of serving static files and setting content types accordingly, etc. But if all you want to do is provide a web service, then this is all you need, because you wouldn't expect to receive any requests for any static files. You would get a JSON RPC call and you would serve it. Right. In Samba, in this demo server, I've got similar callbacks that we had in the MiServer version. We've got the on-request callback, which is first checking if this is the WebSocket, if it is it's handling the WebSocket. If it's not the WebSocket, it serves the index page. And if it isn't asking for the root, then it's trying to serve the static file. So this is my static file handling code, which is allowing me to run this demo. And if we look at the Angular WebSocket, simply just checking, is this the chat service or is it the Bosfor service? And looking into these ones, we get a slightly more cut-down version of what we were looking at before. But in essence, it's the same thing. It receives the message. It sets the date property to the current date. That's serializing it again, and then sending the message to all the connected clients. And the voxel. I don't know why, but these ones tend to get smaller than traditional functions. So it's the same thing that we did before handling the game, the voxel painter example, but slightly smaller. Right. Okay. So if I start this example, we should see that it's doing more or less, well, exactly the same thing as the other example. If anything, I have done a little bit more thorough work on the Rumba version of the WebSocket implementation. So it's slightly snappier. If it actually ran. Yeah, I shouldn't have done this. It was going so well until I ran the last demo. Let's see if any of them work. Oh, this works. I have to change something here that I can't remember. Oh, there we go.
Wi-Fi disappeared for a little while.
Huh?
The Wi-Fi disappeared for
okay. Maybe that was it. Right, okay. Let's just work now. Right. Yay! Shouldn't have done that. Okay. Well, it was a bit optimistic to try to squeeze in both the demonstration of a new library, a HTTP library, as well as WebSocket. But I can report back that my findings for the Rumba library is that it is faster because it's not trying to do that much, so it is a little bit snappier. It's supporting HTTP 1.1. I know Joachim mentioned 2.0, but 1.1, yay! My server doesn't yet. I think it's still on 1.0. And the main difference between 1.1 and 1.0, noticeable difference, is that it's managing keep alive connection, which means that if you serve a page with, say, 20 static files with all the CSS files and small images, etc., etc. The browsers could make 5 simultaneous connections to your server and ask for 10 files on each connection and get them funneled through quickly. With MiServer, each request is a separate connection with its overhead, and it's closing down the connection after each reply.
And if you do same here stuff, it's probably even more.
Yeah. I mean, the reason we put our system behind Apache initially was because of the slow response. All in all, to serve a big project with lots of files, it took about between 2 and 8 seconds if served directly by MiServer, and it went down to half a second behind Apache. And with Rumba, we're still behind Apache, so we haven't actually made the most of it, but it's faster when you get multiple requests.
What we're actually looking at is probably taking Rumba and using that as the foundation for MiServer 3.1.
Right.
Because all that excellent work has been done already. It would be crazy for us to redo that work. But then maybe also approach Rumba from below and actually put some of the HTTP protocols for things to come so that you can throw away maybe the lowest level of code in Rumba and get WebSocket support, and maybe HTTP 1.1, I guess. Maybe not. I don't know. Yeah.
I won't promise anything, but I'm aiming at for 1.1.
1.1, yeah. So the ability to sort of send and receive entire HTTP messages will be pushed down into the free layer.
Right.
And then maybe we'll get very close to the Apache when that is.
Well, I must admit, for my own purposes, I'm quite happy sitting behind Apache because
there are other good reasons to sit behind.
There are so many other advantages, but if you're playing around and you just want to get something like a standalone web service trialed out and developed, then it's great if you can do it without. And in fact, that's why one of the reasons I put in this static file handling, just to avoid having to include Apache in this demonstration. Java? Or no, okay. Any other questions? I will, as I said, the MiServer version of this is available on GitHub, and the Rumba version not yet, because I have yet to talk to Formancer and find out if he's happy to incorporate the WebSocket part of it, and also it's still under development, Rumba itself. I mean, it's working as far as I can see. I haven't found any obvious bugs in it or anything of the sort, but it hasn't been publicly released yet, so I'll need to have a word with him to see when he's happy to release it. And any other questions, if you want to try it out on your own or complain, I will be far, far away from you. I'll be here for the rest of the day. Okay, thank you.